Today we will study structured data type. So what is structured data type? Before that, let's try to understand one concept. It is called abstract data type. Okay, so what is abstract data type? The basic definition is like this. You see that a data type that specifies values that can be stored, operation that can be done, and the values. User of abstract data type doesn't need to know the implementation of details. Okay, this definition maybe you don't understand. Let me clarify. What is abstract data type? If you remember, we have studied int, right? Int, float, okay, float, double, character, string, and so on. We have studied different data types. Do you remember? Yes, no?
Yes, sir.
Okay, good. So we have studied all these data types, but actually these data types has one limitation. Limitation is like this, that you see in our real world, in the real world, everything is a combination of different type of properties. For example, let's suppose a student. Okay, let's suppose student. So student is has a name. Okay, so the name can be a string value, right? Okay, then the student has metric number. It may be integer value. Okay, so uh, it mobile number, maybe integer value, address, a string value, gender, and so on. So if I want to store student information, the whole student information, let's suppose in your class, if I want to store 30 student information, okay, 30 student information, so then how I can store this? Because you see, if I want to create 30 integer array, 30 integer array only to store the metric number. So you see, this will be a separate array. Another 30 array to store the names. Another 30 array to store the mobile numbers. Another 30 array to store the addresses. So you see, 30 one array for 30 sorry, for metric numbers, and to initialize this, then I need 30 lines of code. And to access, again, I need 30 lines of code. And to display, again, I need 30 lines of code. So you see, just for the metric number, I need 90 lines of code. And that is only to store your metric number. And if I want to store the names, then again I need 90 lines to create the array, to assign the names, and to display the names, or to apply some operation that will be extra. And again, for the mobile number, 90 lines of code, and for the address is 90 lines of code. So 90 plus 90 plus 90, it's so many lines. Okay, this is also not a big deal. Okay, I will write. But again, if I want to change one student information, so the student is one, but actually the information is scattered into many different arrays. If I want to change one student information, I need to change several arrays. Like you see, I will search in this integer array that particular student first, and then I will delete, and then again search the particular student in the names array, and then change the name information if I want. So you see, this is a problem, that the information are stored in many different containers. Okay, and I want to just change one student information. It is very difficult. So this is the actual problem. We actually need such a container which can combine the integer, let's suppose the metric number, and the string, the name, okay, and the mobile number, another integer, okay, and maybe marks, float. So we need such a container which can combine integer, string, float, character. In simple words, we need such a data type which is a combination of others data type. Then we can easily represent the student. So the problem is actually this, that we can use arrays, but one array, the limitation of, okay, if we come from very beginning, limitation of data, this basic data type is that it can store only one value. One integer variable can store one value. So in one integer variable, I cannot store all the class information. So if I want to store, then I need to create 30 integer variables. So in the same way for the marks 30, 30 and so on and so on. So variable, the limitation of variable is that it can only store one value. So this is why it cannot represent such thing which is a combination of different data type. There is a little bit solution in array. In array, we can combine value, but the limitation is again that it cannot mix value. It can only combine same data type. If integer array, it can only store integer values. If string array, it can only store string values. But in real life, the information and the objects are actually a combination, like student. Student is a combination of different data type. Let's suppose product. Product is a combination of different data types. Let's suppose mobile, like mobile name, model, price. So you see, the real word is a combination of data type. But what we have studied until now, it can only deal with one data type. So abstract data type means that we will define user defined data type in which there is a combination of built-in data type. User defined data type which can combine, let me type for you, is called, this is the easy definition of abstract data type. Abstract actually means this also, that it is not predefined, it is not given by the C++ compiler automatically, but the user will define it. Okay, so when the option is given to a user that user can define, then again there are different users worldwide, many different programmers. So one programmer may define in one style, another programmer will define in another style. So it means that this data type is unknown in advance. We cannot predict, okay, because it depends on user choice how many built-in data types he or she want to combine in it. Okay, so a user data type which can combine built-in data types is called abstract data type. So one of the, you see, this is another definition, a definition that captures general characteristic without details. Okay, so I already explained to you. So how to combine this data into, so one of the solution is structures. Okay, so the problem of variable and the problem of arrays were solved by structures. Okay, so structures introduced to solve this problem, that if we want to combine different data types, then we can do in structure. So what is structures and how to do? Structure is a container in which we can define we can combine built-in data type. So the word struct is compulsory. You will must use the same spelling. Here you can give any name that you want. For example, you're defining a student, so you can give a name student. Okay, so this will be the structure name. It will be not in angle brackets. Okay, just like this I will show you. And after that, opening curly braces and closing curly braces, and after that semicolon. Inside these curly brackets, you can combine as many data types as you want. Okay, so what does it mean, how to do it? It will be like this. Like, let's suppose you see, like struct student, and you see now int student ID, arithmetic number, and another string name. Okay, another short year in school. Okay, another double GPA, and closing data. So you see, we combined 4 different data types: integer, string, short integer, and double into one structure, and this collectively called student. Okay, now we can better deal with student. Now the student is one entity, one container, and easy for us. No need to write separate arrays and so many lines of codes. Okay, so how to implement this in a C++? So it will be like this, that once you define like this, then after that it actually become a data type. So you can use exactly like other data types, like as we can use like int a, int b, then we can use like student bill, student john, okay, student anyone. So we can use like this. So you see, it's exactly like int, let's suppose a. Okay, so you see, the int is a data type, and now in this case our student is a data type, but this student who defined, we define, the compiler didn't define. And the int who defined, this is given by the compiler. Okay, therefore it is called built-in. Okay, built-in data type, and this one is user data type, and you can give any name that you want. So once you define, it will be like this, because it is a combination of 4 things. student ID, name, and year of school and CGPA. Okay, so it will be like that. Now if you want to access the members of structure, these are actually called members. Okay, like you see, this one is ID members of the bill of the structure, this name member of the structure, year member of the structure, and CGPA member of the structure. So these are called members of structure variable. So how to access it? We can access like this. You see, cin, the same cin we can use, but the variable name, like let's suppose bill dot student ID. You see, note the point, the dot operator, bill dot, John dot, okay, Zolaiha dot, anyone you can use. Okay, you can use like this also, and you can use the same get line function also. Get line, cin, and student dot name and the CGPA. So you see, we get values for that, and then we can display also. So let me show you. An example. Okay, so this is a basic template of C++. Okay, don't worry about this. No problem. You are already familiar with this. Okay, now we can define this structure. You see, before main. So let's suppose you see, before int main, we can define a struct. We will type struct. Okay, and after that, you see, the Visual Studio Code give me the template already. Okay, and here I want to change the name. So let's suppose it should be a student. Until now, if you remember, when we were giving a name to a variable, so we were using lowercase names, because it is a common practice that variable name should start from lowercase, but structure names should start from capital character. This is a standard procedure. It's not compulsory. It is just a convention that most of the professional programmer, they follow this style. So we should give a name but start from capital letter. So student. It is not necessary. I am telling you again. It is not necessary that it must start from S. Okay. This will be the name of the structure, and you see here will be the data. So the data, now it up to us how many data we want to add. For example, int metric number. So I will just type MNO, metric number. Note the point, you will not give the value here. Okay, like MNO equal to something like this. No, because here we are just defining the structure. Okay, it's not the actual values. So int metric number, and after that string name. Okay, and after that should be what, another one, year, int year, or year of study. You can give any name that you want, and after that float or double, it's up to you. Double CGPA, GPA, or anyone you can give. So you see, this is now almost like a student. It represent a student. Okay, so the structure defined now already. So you see, this one compiler, before coming to the main, compiler will find it. Oh yeah, the user has defined a new data type. Its name is student, and it has 4 data members. These are called data members. Okay, then inside int main, exactly like built-in data types. In built-in data type, anytime we can create like this, right? So in the same way, we can create student. You see, you will use this name, not this name. This name now you can use as a data type. Okay, student. So whose name I should use? Anyone? Alex. Okay, student Alex. Okay, so now if you look at this, we created one complete student, and this student, you see, even the Visual Studio Code can understand that Alex is what? It is a student. Okay, now I can assign values to this. For example, Alex dot, you will use the dot operator, and you see, as I just press dot, I get all the members here. So you can see this, Alex dot metric number equal to 1 2 3 4 5 semicolon. Alex dot name equal to Alex. It should be the same. Okay, Alex dot year of study equal to second year or first year, Alex?
First year, first year.
Oh my gosh. Okay, first year. Okay, and then Alex dot CGPA. Let's suppose Alex is a very good student, 3.88. Alex, is it okay for you?
Okay, okay.
Okay. Yeah. Okay, so you see, we can assign also like this. Even if you want, let's suppose the three I assigned and the fourth one I don't want to assign. I can do like this: C out, enter CGPA. Okay, and backslash n, let's suppose, and here I can read UC in. Okay, in C in you will have to use the same data operator, LX dot CGPA and semicolon. So you see, different ways you can initialize also, but note the point I am repeating again, you will not initialize here while defining. No, this is just the definition. This is for compiler. You know that compiler is a stupid thing. If you don't introduce, then compiler don't know what is student. So this information is for compiler, that hello compiler, remember, whenever I use the word student, it means it is a structure and it has 4 data members. Okay, don't give me any error. Then when compiler comes here, then understand, oh yes, okay, no problem. Then you see the initialization you can do like this also, you can get from the user also. So once you get all these values, now you can display. Let me type cout. Let's display structured data. Okay, backslash n, semicolon, and here cout. So not this one. Cout Alex dot metric number. Should I use some prompt like metric number equal to this, and then semicolon. Okay, and after that, should I copy? I think I should copy a bit. Okay, name equal to Alex dot name. Yeah, you see, and again, year of study equal to Alex dot year of study. Okay, next one, CGPA equal to Alex dot CGPA. So in this way, you see, we define, we give the values, and then we define. Okay, now let's run. Yeah, you see, enter CGPA, it's looking for the CGPA. So let's give a good value, good CGPA to Alex. Alex, you are happy with this?
Happy.
Okay, good. So you see, I gave this CGPA. So now let's display the structured data. Oh, I didn't use any backslash n. Oh my god. Let me modify again and do it again. Okay, so this ENDL, and let me copy this. Copy, paste, and paste. Okay, now let's run again. Okay, this time if I run again, so this time again I should enter 3.78. Okay, now let's display the structured data. Metric number is this, that whatever we have given, name is Alex, year of study is first year, and CGPA is this one. So you see, now we are dealing with a real world objects, real world things. You can define now mobile, you can define now product, you can define now inventory, whatever you want. So is like we are slowly going towards a real programming. So to display the values of a structure, we already covered like this. We cannot do like this, not the point. You see, like cout mobile, no, cannot. because the whole mobile is actually it has 4 data member. Then the cout don't understand which one I should display, and it cannot display the whole thing for you, but we need to access through dot operator, and it is also called member access operator. Dot operator, member access operator, like bill dot student id, bill dot name. So it will so you can use cout and in statement. In this way we already covered. Okay, again you cannot compare like two structure variables like this, like bill equal to William. No, because again it has different data member, it has different data member, so it will be compared member by member. You see, bill dot student id equal to William dot student id, then computer can do it. It cannot do like this. Okay, initializing a structure, you can initialize also because sometimes it's difficult to give write so many lines and different lines, one member and another data member and different line. So you can easily initialize using like array. Okay, student, let's suppose s equal to and curly bracket, not the point, curly bracket, and then the number of values. So you see the student was having 4 data member, so 4 values are provided here. If so in this case, you see the name will be John and the CGPA will be this one, meaning to say the first value will go to the first data member, second value will go to second data member, third will go to third data member, and so on. Okay, so you can do like this also. You can re-initialize again if you want. You see, even after initialization, if you want to change, you can change like this if you want. Okay, if let's suppose you initialize like this, student bill equal to only one value. So we know that the bill has 4 data members and you provided only one. So what will happen? The rest of 3 data members will have default value. The string will be nothing. Integers will have 0, double and float will have 0.0. So if less number of value, the first like this one value, it will go to the first data member. And note the point, the value and the data member data types should be matching. Like we know that the first data member is integer, so the first value should be integer. If you provide wrong one, then you will get an error message again. Okay, so note these points. Okay, so this is another example similarly like that. So we already know like structure, imply pay. So string, the name of the employee, and teacher, employee number, pay rate, hours, and gross pay. And in this way we can create several implies. You see, employee pay, employee number 1, employee number 2. So once you define this structure, after that you can define as many variable as you want. These are called instances of the structure. It has a bit different name. It is exactly like a variable, but we mostly called instance. Okay, instance of the structure. Okay, instance. Instance, you can say like a copy of the structure. You know that maybe you have seen many times that when there is a construction, so actually the company doesn't start the construction first. They design the overall thing, the overall map on paper first. They design everything. How many floors will be there, how many each and every aspect, how many rooms will be there, what type of rooms will be there, how many windows will be there. So they define everything on paper first. Actually, this definition is exactly like the paperwork of a construction. But once you define everything on the paperwork and later on you construct a house, okay, and you construct a house using that paperwork, this house is called instance of that paperwork. So now this imply 1 and imply 2 is instances of this imply pay. Okay, next one, array of structure. You see, this is related to your assignment also. Now, once we have one student, now the question is how to, if I want to store 30 student, now I can put the structure inside the array. Then it is quite easy. I can store the whole student information in array, but in a style of student. So let's suppose this is an array of 30 students, okay, like this. So on the first location will be one student, okay, but actually this student will have four data member. Okay, this will have 4 data member. It will be like this will also have 4 data member. Okay, so this time the array will be a bit complex. okay, but still will be one structure and easy to deal with, easy to find, easy to change, and easy to modify. Okay, now the only thing that you know that when we create array, then the array has indexes. Okay, the indexes start from 0. Okay, so we can actually access like the first student stored at index 0, second student at index 1, and so on. So in this case, in this way, we can access, but we will have to access through data members also. Okay, let me show you all these things in detail uh, in example also, but let's go through like this. Yeah, you see like one constant 20, and after that student, you see this is the structure name, and student list, and this is the size of the array, which is this constant. Okay, after that you can access the array members like this. Student list 5 means the sixth one, because index is from 0. The sixth one dot student id. Okay, so in this way we can display. So let me show you here again practically. Here I will create, let's suppose, student list. Okay, and this will be array, and array has a size. For simplicity, I will use 3, because otherwise I will need to enter so many values. Okay, so student list 3. Now if I want to access these values, then I can access like this: student list sorry, student list, which one? It is array, so the first one. Okay, and dot. Okay, dot. Now you see it has the members. So metric number equal to 1 2 3 4 5, and again student list 1 equal to dot name equal to who? The same Alex. Okay, Alex, your name is easy. Student 2 dot, yeah, year of study, yes, okay, is equal to 1 semicolon. Oh, it's not year, is year of study. Okay, now is student CGPA is equal to 3.88. Okay, so you see we can easily insert like this. So in this way, oh, no. It should be the first one. Sorry, you should correct me. The first one is have everything. You see, it should be the first student which is stored on location 0. It will be like this, that array of 3 students, but this one is, let's suppose, Alex. Okay, Alex. So Alex has metric number. Alex has a name. So you see, year of study, CGPA, but all those are where? At index 0. This is why here it should be index 0. If I say 1, it means this one. If I say 2, it means this one. Okay, yeah, so this all will be 0. And in the same way, we can give now, for simplicity, if I copy this and maybe like a second student. Okay, and here if I paste, and here I will just replace by 1, and here I will give, let's suppose, different value, and this one should be who? One of my student, Natasha. Maybe any one of you also have the same name. Okay, so year of study is this, CGPA, let's suppose the same. And if I copy once again, then you see in this should be the third one. Okay, the third student, and this should be someone, and this should be, let's suppose, Aisha. Okay, and let's suppose like this. So 3 completed, and after that I can use cout statement. Okay, so you see it has a lot of repetition. The same thing again and again and again and again. And if there is a repetition, then we should use a loop, right? I think loop is the best. So I will use what for int I equal to 0 semicolon I less than 3 semicolon I plus plus. Okay, and then here I can do what? I will just type cout student student list I, because the I for the first time is 0, I dot metric number semicolon, and I will copy. I think we should have a new line also. Should be like that. ENDL, and then I will copy this and paste. And this one should be name. Paste again. Name. Year of study, and paste again, and dot CGPA. Okay, so in this way we can display. So I can say like this as cout the student number which one? I, student number I, but plus 1, because the I is 0, so it should not be 0. I plus 1, and then details, and then backslash n. Okay, let's see. Oh, semicolon. Any confusion until now? Hello?
No, sir.
It's clear, huh? Oh, okay, good. So if I run now, I hopefully will see the details.
Yes, sir.
Yeah, this should be true. Now, you see, previously it was giving me a random values. So I was surprised. Why random values? Okay, now we have 3. 1, 2, 3. Okay, so this time should be okay. Yeah, you see? No random values. So I hope you got how to create array of structure. And you see now, like we are dealing real world things. Now you can create a whole accessory shop. Nested structure is exactly like a nested if, nested for loop, nested any loop. So nested means when one structure is inside another structure, that is called nested. Okay, for example, let's suppose this is one container. Okay, this is one container, let's suppose. So inside this another container, this is called nested. Okay, so we can put one structure inside another structure. Okay, so how to do that? That is the way like this. You see, let's suppose we have one structure, personal information, like name, address, and city. So you see, this is one structure, and after that we have another structure, student. Okay, and in the student structure we have student ID, but you see, int student ID, but after that personal info is what? Personal info is this one. So you see, we put one structure inside another structure. This is called nested structure, and the value p data, and then short, you see, this is the same built-in type, no problem, and double, and this. So we put this one inside this student. Okay, so we can do like this. But one thing, you see, when you are accessing this one, then you will have to access like this, that the student dot the other structure. Okay, like let's suppose p data. Okay, p data, and then dot, because it is two levels. Student dot the nested structure name dot the nested structure data member. So when there is a nested structure, then you will have to use two dots. Okay, two dot operator. The first, uh, the first structure like student here. Then the second structure, I will write two. The second structure, this one, the variable. You see, the second structure variable inside it, and then dot, and then the members of this, the p data, and it has three members, so it will have three. Okay, so to do this, I will create a struct, and this one I will give a name.
Sir,
Yeah, thank you. I understood. Yes, you should help me like this. So struct, and this time we should give a name like marks. Let's suppose subject marks. This should be capital. Subject underscore marks. Okay, and here we should provide the body and semicolon. Don't forget the semicolon. Okay, and here I will give a name like float C plus plus C plus plus semicolon float. You have other subjects. What? I will just type English. Okay, no problem. You can understand English, and then float maths, let's suppose. Okay, so in this way we can define, create like this, but inside this subject marks, I want to put the student, because these marks belongs to who. So this one I will put student. Okay, and the student will be, not the student is the name. Here we will create instance of that student. So let's suppose here I will write Alex again. Okay, so you see, now you see we put one structure which is defined outside inside another one. This is called nested structure. Okay, so I will delete the array because I want to show you only the nested concept here. So now I will create instance of this structure in int main. Okay, so here I will create here I will create general one like to std. Okay, let's suppose std. The std stand for student, and here I will create Alex. No, Mara. Student 1. Student 1. Let's suppose like this. Okay. Semicolon. Now you see, if I want to give information to this student 1 now, then student 1. Okay, but not like this. Student 1 dot this one. I think I should give here personal. Yeah, I think personal. Yeah, okay, like this, to be a bit clear. Okay, student 1 dot personal. Okay, but personal dot again is what? Metric number is 1 2 3 4 5, and student 1 dot name equal to Alex. Okay, and student 1 dot name done year, no, not year of study. Year of study is first year. Okay, and then student 1 dot CGPA is equal to 3.89. Wow, you improved already, Alex. Okay, so now you see the personal completed. The personal. So if you see, these four were nested structure. This is why I used two levels of access. The first level, then dot, the second one, then dot, the data member. Okay, now this time we have uh, the only the other. So student 1, not the second level. The second level, two level of information. Student 1 dot just C++ marks is how much. So let's suppose you are very good in C++, 89 semicolon. Student 1 dot English equal to maybe 80, and student 1 dot math equal to, let's suppose, 85. So you see I hope that you understand that where we are accessing the nested one, we are using two levels of dot, and actually it can grow. It can grow in this way that maybe inside this you put another one like third layer, then here will be dot 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 and again dot, like three dots you will have to use. So different layers of nesting is possible. Okay, so now the same thing we can use in cout statement. Okay, so cout, let's display nested structure data. Okay, backslash n semicolon. I will just type like this, then later on I will modify. Paste. So cout this student 1 dot metric number. Okay, like this, and maybe like E and L. Okay, now I will just copy this, copy the paste. You get what I'm doing, right?
Yes, sir.
Okay, so here I will copy this and replace these things. You see, because we are using cout now. Okay, just like this, just like this, just like this. We are not assigning the value, so no need of this. Okay, got. I hope no problem. We can say also, yeah, it's okay. Let's run. Yeah, okay. Let's see. Uh, oh, is here. You see, let's display nested structure data. So the first one, metric number, you see, LX, and year 1, and these four are the nested uh, structure data, and the rest are C++, English, and maths. So in this way, we can nest structure into one. Actually, you can nest several if you want. You can. It will be a bit complicated, but you can. So in this way, we can put nested structures. I think we already done. So we can send structure to a function also. You see, like for example, if you want to define a function, let me define here a function void display. Okay, and we will send what? We will send this one now. Okay, this. So semicolon. You see, we define a function that it will return nothing. Its name is display, and it will accept subject marks structure. Okay, so actually I can define this one now anywhere. Let's suppose I define here. Okay, so no semicolon and then curly brackets like this. So here I can copy this cut this code, because this is related to display, right? Cut and paste here, paste here. But in this case, I will change okay, mark subject, and I can give a name. Uh, let's suppose student. Okay, student. Okay, and now you see this argument I will change here everywhere. This, 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 this. Oh, should be this, should be this, should be this. Okay, so you see, we declare a function, we define a function, and let's call from here display. Okay, display, and what's the name? Student 1. And let's send the student 1 to this. Okay, this variable will copy to this variable, and here we can display everything. So it will have the same result as we did previous time. Yeah, you see, exactly the same thing. So meaning to say, we can send structure to function argument also, exactly like a built-in variables. So I hope is clear. This is also programmer data type, but it consists of values known to enumerators. Enumerators which represent integer constant. Most of the time we need integer constant, like for the array size and for like pi, like so many time we need to create integer constant. But this one is a bit easy way to create the enumerator, but internally it will have values integer. So you see how to create enum. This is data type like integer, float, double. So enum, you can give a name, any name, in this case like day, and you see here Monday, Tuesday. So you see this Monday, Tuesday, Wednesday, Thursday, Friday, these are enumerators. Okay, it's these are the constant, but its internal value will be integer. Okay, so this identifiers the Monday, you see this is now like a constant. We can use like Monday, but computer know what is actually Monday. The first value will have actual value 0, the second will have 1 and 2 and so on. Okay, so Monday, Tuesday, Wednesday. So if you just click type now see out Monday, then computer can understand because we define already here. Okay, so this is called enumerator, and they represent the values they belong to the day data type. So we know and computer know that it is from the day data type. Okay, so we can do like this. You see, enum, day, Monday, Tuesday, all this. Note that the enumerators are not string. You see, it's look like a string. Monday, Tuesday, it look like a string, but actually it is not a string. So they are not enclosed in quotes. So you see, we have not enclosed like this. No, because it is not strings. Enumerators are actually short integers. Okay. So then you can do like this also. You see day, work day, and after that this statement is like a variable. Okay, so we can do like this. You see work day equal to Wednesday. You see this one is a variable, but you can put any day which has been defined here. Okay, you cannot do outside any value, but already defined values. So it means that enumerators is actually a short list of constants, string constants. Okay, but in memory, it, as I told you, it will be like this, that the Monday will be actually 0. If you display the Monday, see out Monday, it will display 0. It will not display Monday for you. Okay, it is just for understanding purpose. So Monday equal to 0, Tuesday equal to 1, and so on. They start from 0. So using the day declaration, the following code, see out Monday, you see Monday, Wednesday, Friday, this will proceed what? Monday will display 0, Wednesday will display 2, and Friday will display 4, and so on. Okay, you can assign, you cannot directly assign an integer to any. You see, like work day equal to 3. No, you cannot do like that. Yeah, because it is not actually a real integer values. It is enum data type, enum, enum. Okay, instead you must cast like this. You see the type that we have defined previously. Okay, this you can give any name, but once you define, then become a data type. And now you, if you want, you can cast. Static cast means conversion. You can convert these 3 to this day data type and then can assign here. And 3 means 0. Let's see, 0, 1, 2, 3. 3 means Thursday. Okay, then it will represent Thursday. Yeah, like this. You see. Okay, you cannot assign an enumerator to integer also. You can assign. This is integer. Okay, and x equal to Thursday, because internally computers treat the enumerator as integer value, so integer can get, but the reverse is not possible. To enum you cannot assign integer, but to integer you can assign enumerator. Okay, so in this way we can compare also, because Friday means 4, Monday means 0, so 4 is of course more than 0, so you can compare also. So enumerator is nothing, just a small a list of string constant. Okay, which is internally represented as integers, but easy to use, easy to remember. Like you see Monday, Tuesday, Wednesday, it looks like English words, but computer store internally as a integers. So like this, you see const int number of days 5, and double cells this and total int this. So you see, now you see here we have already defined at the beginning enum day, Monday, Tuesday, Wednesday, Thursday, Friday. So you see that the loop is like this. You see, for index equal to Monday, index is less than equal to Friday. You see, it looks like a number day names, but actually computer know that Monday means 0, so index equal to 0 because array start from 0. So no problem, you can use it like this.